The electrons this battery makes cannot pass through the battery itself. They travel the long way, around the outside wire. 10 quintillion electrons take that trip every second. A 1 with 19 zeros. What pushes them out is a chemical reaction running quietly inside the cell. The trick is inside this little can. We made it visible. This is a battery, a device that turns chemical energy into electricity. What happens inside, that makes the current flow. The input is a chemical reaction, the output is current. Let's look in between. Let's look inside. This is the cross-section of a cell. On the left, the negative electrode. It sends electrons out. On the right, the positive electrode. It takes electrons in. Between the electrodes sits the electrolyte, the pathway for ions. The thin film in the middle is the separator. It keeps the electrodes from touching. On top are the terminals, the way out to the external circuit. Here is the core. At the negative electrode, atoms give up electrons. This is oxidation. Those electrons cannot pass through the cell, so they are pushed out into the external wire. They travel the long way around and light the bulb. That flow is the current. Reaching the positive electrode, the electrons are taken up. This is reduction. Meanwhile, inside the cell, ions take the short way across the electrolyte. Electrons outside, ions inside. Two separate paths close the loop. In physics, the voltage the reaction produces is the electromotive force. Draw current, and internal resistance drops the voltage. Terminal V equals EMF minus I times R. The total charge you can draw is the capacity, measured in amp hours. The more current, the lower the terminal voltage. The line droops to the right. Now, let's make the load heavier. A heavier load draws more current, so internal resistance sags the terminal voltage. Ease the load, and the voltage recovers. Push current the other way, and the reaction runs backwards. That is charging. Wire cells in series, and their voltages add up. NovaSolver. Physics made visible.